All, this is Dr. Mobeen Sayed from drbeen.com. Welcome to one more show. So, thank you very much for patiently waiting for my lectures to resume. Our last lecture was on this Thursday. Then on Friday, I became ill with COVID once more. And this time, me, myself, my wife, and my child, Hamdan, my son, he became COVID positive as well. So, I'll tell that later on. Um, I think they became COVID positive, tested COVID positive for the first time. I have tested positive before as well. So this may be their first time. Okay, so let's start. So I have to catch up for these last 10 days. I have to share what happened at FLCCC, whatever I can share. I have to share what are my COVID symptoms, very different from the previous ones. And I want to do this study first, and then we'll continue on the other points. Maybe we'll do 2 lectures today. Okay, with this, let's start. So this is drbeen.com. In the description, there is a link that has a plan for Dr. Bean that is the most inexpensive plan you would see, and that is a one-time fee. Here is the study that we're going to talk about. This is a Thai study. I heard this has become accepted as well, but I couldn't find it. So I'm still going to go off of the preprint. This is a Thailand study, preprint, cardiovascular effects of the BioNTech mRNA COVID-19 vaccine in adolescents. This study was for the school age children, actually school going children, 13 years to 18 years of age. The smart thing they did, these researchers, was they actually did a baselining. That is, after the second dose of the vaccine, on the day of the vaccine, they did the cardiac workup. I think they did the EKGs even before. Then on the day 3, 7, and 14, day 14 was optional. Meaning, this was not a study where they said, well, if something happens to the child, come back. And if they come back with a cardiac symptom, then they add them to the study. This was a prospective study. This was an amazing study. So this is a study I'm going to discuss today. I have some other studies here for context. This is another study for context. This is January 25, 2022. Myocarditis cases reported after mRNA-based COVID-19 vaccination in the US from December 2020 to August 2021. This one, what it showed was, and I have, as you can see from the highlight, I have done a separate discussion about this. This study showed that the rate of myocarditis was in the age group 12 to 17. I think 12 to 13 was 130 times higher than expected. And what do we mean by expected? When FDA authorized vaccines, there was a background case expectation to say in the background, that is normally without any vaccines, this many number of myocarditis occur in this age group. And then they observe any additional myocarditis, and those will be the expected now after the vaccine. So FDA's debrief documents, I'll have them open as well. They showed almost not much of such an issue. But anyways, this study showed that there was actually 130 times higher number of myocarditis. Then this is another letter, myocarditis after BioNTech vaccination in Israeli adolescent. This is March 10. I'll discuss this as well. This is another document. I'll discuss this too. Then I have for context this Seattle Children's Hospital study for myocarditis, vaccine caused or associated myocarditis in the children, and how long it persisted. So I would like us to just hold on to one thought, and I've done this discussion separately as well. The authors in this study said in a cohort of adolescents with COVID-19 mRNA vaccine related myopericarditis, a large portion have persistent LGE abnormalities, imaging abnormalities, raising concerns for potential long-term effects. So this is something that was already kind of on the radar, but there was no study that actually said before the vaccine, this was the heart's status. After the vaccine, this is how the status changed. That is this study, Thailand study. Okay, so with this, let's start. And my apologies if I sound a little congested. That is just COVID. Now let's continue. So these are our gifts for humanity. They're continuing. Let's start. This study is myocarditis. So in this particular study, they use, if I go back to study for a second, in this study, they use the word cardiovascular effects. The reason they used the cardiovascular effects is that they looked at the EKG, for example. They looked at tachycardia or heart rate increase, heart rate reduce, arrhythmias, and then biomarkers and labs as well. So they even the imaging too. They also did the echo as well for left ventricular ejection fractions too, meaning they had a complete cardiac profile. And what I want to focus on is not the whole profile. I want to focus on an important part of this that is shown here. This one, 7 participants, 2.33%, exhibited at least one elevated cardiac biomarker or positive lab assessment. This is what I would like to convey to us, that what does this mean? And what does this mean overall in the bigger picture of the vaccines? So back here, so I'm focusing on the subclinical myopericarditis. Study is prospective. Prospective means that they were ready as the vaccination started. Patients, I'm saying the recipients were healthy individuals, children, school-going children, 13 to 18 years of age. There were total, I believe, 314, 13 were lost to follow-up, 301 were the one that finally made it with the follow-ups. What they found, the summary of the study is this. What they found was 2.33%. 2.33%. It is not 2.33 per million doses or 2.33 per million individuals. This is 2.33% of the vaccine receiving children had some sign, symptom, lab marker of cardiac inflammation. This is something that is really important. For example, in one child's case, and I would go over those table a little later, in one child's case, that child had no biomarker raised, so troponin levels were not raised, CKMB levels were not raised, CRP or C-reactive protein was not raised, ESR was fine. So you could say that everything was fine, but the child had pericardial effusion. That is, they had accumulation of fluid around the heart because of the vaccine, probably the immunity from the vaccine and or the spike protein. Now, nothing else was showing. This was subclinical as well. And even the markers were not showing up for this child. So tell me this, isn't that child at a greater risk now? So when I was reading this study, I kept thinking that the best thing to do is, number one, reevaluate the cost benefit of the vaccines anyways for various age groups. One. Secondly, have trials with the prospective studies like this. Two. And three, children who are getting vaccines, make sure that we ask them to take rests for some time, because they may not have symptoms, they may not even have labs, but still have pericardial effusion or inflammation of the heart. And if they run around, if they do exercises, if they, just like they do the kid things, children things, they can end up damaging their heart for a long time. This is a different discussion. Seattle Children's Hospital said that myocarditis caused inflammations signs in the imaging were present even after 8 months. So that is a separate problem. And then a heart that may be inflamed and a child or parent or doctors do not know and the child is running around, that can pose a different kind of a risk. So these have to be seen. Now, in terms of I'm still on the summary, in terms of the cardiac effects, all of them, EKG abnormalities, rhythm abnormalities, labs differences, etc., all of them together, 29.24% of the children developed some cardiac effect after the second dose of Pfizer BioNTech vaccine, especially males, boys. And again, I'll show you that over here as well. So if you see here, cardiovascular effects were found in 29.24% of the patients, ranging from tachycardia, palpitations, and myopericarditis. Okay, so this is the basic summary. The next few things that I want to do, a few concepts that I want to get across are the following. A question I want to raise in your head and then answer that a little later. That is, okay, fine. So 2.33%. Is that expected? Does that happen normally as well? Or is that slightly elevated from the normal rate? And so if that is the case, then no big deal. Or is this an abnormal number? And if it is an abnormal number, then the second question in your mind should be, how abnormal? How bad this number is? How greater the number is compared to what is expected? So these are the two things that we would like to understand. Third thing is I'm actually going to explain what is troponin T and CKMB and where do they come from and why do we detect them, etc. So that's the second part of the discussion. And then the last thing I'll do is those 7 subclinical patient symptoms. We'll go over them one by one. Okay. So context. Now, please keep in mind, here is some data to keep for this context. One child out of these 301 ended up in ICU because of myocarditis. 1 in 301. 7 total with cardiac inflammation labs or markers. 7 total out of 301. That is 2.23%. Good. Now let's start with what we are seeing otherwise before this study. Authorizations of these vaccines. Pfizer BioNTech's authorization, 16 years and more. I'm going to open up the authorization document. So give me 1 second. And I will bring that over here. Sorry, I usually keep them open beforehand, but okay. So if you see here in this document, if I go to ventricular, you would see this is a very interesting document. This is the FDA's briefing document for the steering committee that approves or authorizes or recommends the vaccine. This is BioNTech recommendation. I have done a complete discussion about it. Here, look at this one. 2 severe effects in the BioNTech group and none in the placebo group were considered to be by the investigator, but not the sponsor. Meaning Pfizer said, this is not us. But the sponsor said, for example, let's say FDA said, this is you. As related to study vaccination. Now, what are the 2? Look at the 3 out of which the 2 they chose. The 3 events that occurred, and I hope you're surprised at just 3. So the 3 events are shoulder injury, that's 1. Ventricular arrhythmia in a participant with known cardiac condition, that is another. And lymphadenopathy temporally following vaccination. 3 severe events. And in FDA's opinion, Following review of the adverse event narratives, two of these events were considered as possibly related to vaccine. What do you think these two were? They said, you know what, this shoulder injury and lymphadenopathy seems to be the vaccine. This heart thing is not vaccine. So in this briefing document, they simply said nothing, no cardiac events, nothing. So this was one. Now, if I go back here, so original authorization, no issues expected, no issues observed. And January 25, 2022, I have already shown you these studies in the references and the links are in the description. The study in JAMA, that is VAERS-based study. It said myocarditis cases after mRNA, and I have done that discussion. I showed that before as well. About 70 cases per million in 12 to 15 years of age compared to expected 0.53 cases per million doses. Expected was, so imagine if we are FDAs or we are authorizing or recommending committee. We are told that, hey, you know what? With the vaccine, the expectation is 0.53 cases of myocarditis per million doses, or every 2 million doses would cause at least one patient to have myocarditis. That's what was said. And this study had found 70.73 cases per million, which is 133 times higher than the expected. Now, we did this discussion as well. Did you ever notice anyone stopped and said, we need to look at this study and figure out why this number is this way? Now, I cannot compare this study's number because this is per million doses to the Thailand study's number, the study that we're discussing today, because that is cases out of the individuals who receive the vaccine. This is per million doses. So there is no one-to-one comparison. So I'm going to leave this comparison. Just here, the takeaway is vaccines have been causing myocarditis, which is more than expected. Okay, then here is the Israeli study. I showed you the link to that. This study found that 12 to 15 years of age children, they had the risk of myocarditis one case out of 12,361 persons, not doses, persons. So we can compare actually this one to this Thailand study. One case out of 12,000. This study says that CDC mentions that the expected cases in 12 to 17 years is one case out of every 16,129 children who receive the vaccine. So I would like you to keep this in mind as well. One out of 16,129 is what FDA expects, CDC, FDA. What did we see in this Thailand study? 7 out of 301, 2.33%. Or even if you say, the remaining 6 who are subclinical, we are not going to look into them and not acknowledge them. Then there is 1 out of 301. And I would actually show you the data for the remaining 6, and you will see that you would acknowledge that they had cardiac problems. So I would consider all 7. So you consider 7 or 1, still it's a very high number. 1 out of 301 is very different from 1 out of 16,291. Or 2.23 or 2.3 out of 100 is very different from 1 out of 16,000. Okay, so that I'm building this context to understand how different the actual results are. If the study is done from prospective state, that is, you start observing the patient as soon as they receive the study. So you could say, why are these studies not showing these results? Because they're not prospective studies. They said, you get your vaccine, go home. If there's a problem, come back and we will manage you. And maybe as part of that, there will be some studies as well. Now, those children that have subclinical myopericarditis, they might actually not come back. They might actually, a few weeks or days later, have something unexplained happen to them. This is the risk in here. Okay, so then the third part of the context, Seattle Children's Hospital study. This study, they said that everyone, I read that to you, every child who had myopericarditis, 3 months later, 5 months later, and 8 months later, all of them, or almost all of them, had still the signs of inflammation in their hearts through that LGE imaging. And the when I did that talk, the researchers say that we would continue to follow up and we'll do a year later and so on. So I think we should follow up on them and see how they are doing. Okay, so what does this Thai study change? What they're changing is the following. Number one, for the first time, a study is showing a subclinical presence of myocarditis, pericarditis. No study had shown that before. Number one. Number two, this number, I'm only talking about these 7 patients. I'm not talking about 29.23 or 29, almost 30% cardiac effect. I'm just talking about this small set. This small set is very high as well. Larger set, all cardiac effect 29.24 is high. 30% of the children getting a vaccine developing some cardiac effect. That's a very high number. 30%. Then myocarditis, 1 case or 7 cases. I consider 7. These are very high as well. That is what this study has added. In my opinion, with this study, we should now stop and say, by we, I mean FDA, CDC, they should now stop and say, you know what? We need to figure out, number one, we need to reproduce this study. We need to look into this data. We need to verify this is a correct study, correct data, makes sense, maybe even try to reproduce it. And then make decisions based on these studies. More data is coming in. We have to, 2020 is ancient times for us in terms of this pandemic. 2020 was 100 years ago in terms of this pandemic. We are in a very different phase. So we have to continuously evolve our thoughts and our messaging and our data and our work. So before I go into the study a little more deeper, I wanted to share what is troponin or cardiac troponin. Where does it come from? Why do we measure it? And what does it mean if it is measured? And same for this CKMB. So let's start. Look, in our heart, all muscles, not just our heart, all muscles have contractile units in them, right? So they have parts, microscopic tiny parts that can contract. These contractile units are made up of many proteins. Majority of the things inside the cell that are functioning are proteins. So here is a myosin protein. It has these myosin heads on it, which are contractile head. This almost is like 2 parallel bars that are walking on each other, and they contract or relax doing that. Here are some more protein. There is these blue guys are called actin proteins. Then there is this tropomyosin, this little red, orangey ribbon. But what is more interesting is this cluster here. This cluster interacts with the head of the myosin for contractile function. In this cluster, this blue little protein here is troponin T. This troponin T is a protein inside the cell, and I have a diagram later on to show that. Inside the cell, when cell is damaged or when it is inflamed, then these proteins can spill out of the cell. This is like if you have, let's say you have a purse. So let's say you're a woman and you have a purse, and inside the purse you have money, and somehow the purse fell and the money spilled out. Right? That is the same thing over here. This whole thing is packed inside a cell. When the cell gets damaged or cell becomes inflamed, it starts leaking stuff from inside. we can detect those proteins floating around in the blood. And based on that, we can say, man, the heart is getting damaged. So these labs, these biomarkers present in the blood is an indicator that there is an inflammation going on, either inflammation or ischemia or necrosis or all three of them. In this case, possibly inflammation. But in the case of Seattle Children's Hospital, they actually saw that there was more than inflammation as well. But anyways, this little blue thing, troponin T, can come out. So here, the bigger picture, this is a heart. This red thing is the muscles. Muscles are made up of contractile units. Within the contractile units are these little proteins. When the heart tissue is insulted, how does it get insulted? For example, there are many reasons that heart can get damaged, right? The lack of oxygen can damage it. Incorrect electrolytes can damage it. Acidic environment can damage that heart. Lack of energy can damage it. Lack of oxygen can damage it. You put more pressure on the heart to do more work, it can damage that. Chronic hypertension. There are so many reasons that heart can become damaged. However, an important reason is immune attack. So when we give a vaccine, so let me back up for a second. In this study, the author said, we do not know what caused it. And I think that is fair that they, instead of going and saying, hey, we need to now do some biopsies on the heart tissue of these children and try to figure out what was going on, they cannot. So they just did not speculate in that area. They simply said, we observed the inflammation. What caused it, we don't know. So I will put that forward because we have done other studies that have discussed that. So one possibility is the spike protein's presence that can cause disruption of the cardiac tissue cells. It can bind to ACE2 and cause inflammation versus pro and anti-inflammatory system to become imbalanced. Spike protein, when connects to ACE2 on a cell, it can cause a cell's function to be disrupted. Spike protein, when attached to the cell, can cause nitric oxide production to be reduced and reactive oxygen species to be increased, cell damage to occur. There are so many pathologies. For 2 years long, we have those. That is one possibility. If it is not spike protein, and let's say it is autoimmune antibodies, what happens is, in that case, this is molecular mimicry. In molecular mimicry, let's say we gave a spike protein, messenger RNA made a spike protein is looked at by the immune system made the antibodies against it. Those antibodies are not only attacking the spike protein, but there is a molecular mimicry. That means part of the spike protein epitope or detectable bindable region is also seen on the heart tissue. So those antibodies that are supposed to attack the virus are now attacking the heart. So these immune cells are standing over here and telling the heart cells that, hey man, you look like a spike to us. They're attacking it. So when they attack it and the cardiac tissue becomes inflamed, that is when all these little things start spilling out of them, like little jewels coming out of the the bags. Similarly, so this is about troponin. Troponin's presence outside. Now, think about it for a second. Troponin is part of contractile machinery. Troponin's presence in the blood means some contractile machinery got demolished and the pieces spilled out. That is why we find those pieces running around in the blood. Secondly, now I'm going to the CKMB. In every cell of our body, we have enzymes. Enzymes are doing various things. Similarly, heart cells have enzymes as well. There are two interesting enzymes that we can find in the blood and measure them. You may have a question that, well, are these just these 2-3 things that are spilled in the blood and not the rest of the things? No, actually, many parts of the cell will be spilled. And there is no discrimination to say troponin can go out, but the myosin cannot go out, or troponin I cannot go out. Myosin may not be able to go out. Myosin is a big threat, so it may not go out. Tropomyosin may not go out. Actins may go out, and the others. But we have to make sure that these are not present in the blood from other cells. So we have found some proteins that we can reliably latch onto and say these can only come from heart. The other proteins may be coming from the heart or from other tissue, and we cannot differentiate. This is why we selected these proteins. So that means there are actually more things in the heart getting spilled in the blood, but we are just not measuring them. We are measuring these. So CKMB, these are two enzymes present in the cardiac tissue as well, within the heart cells. These are phosphocreatine kinases. Phosphocreatine kinases. One is called CKM and the other one is called CKB. Together, these two little brothers are called CKMB. And when the heart is damaged or the inflammation occurs, when the internal machinery spills out, then these CKMB guys, these two enzymes are found in the blood as well and can be measured. So presence, think about it for a second. Presence of CKMB, presence of troponin in the blood is an indicator that something is going on with the heart, that within the heart's contractile tissue, some machinery, some contractile units are breaking up, some cells are breaking up, or sometimes the cells don't break up. What happens is in inflammation, it is possible that a cell doesn't really tear down, but it just becomes too much swollen and fragile. And when it becomes swollen, and there are reasons for why it becomes swollen. Of course, it is under attack by the immune system, right? So when it is swollen and it is like puffer fish like cell, then there are holes that can appear. Integrity of the cell can be compromised. And from those places, these enzymes can spill out. This cell can still recover. The difference between the inflammation, just the inflammation, and actual necrosis is that necrosed tissue cell is dead. It cannot recover now. It is gone. But ischemic or inflamed can still be recovered. So this could be because of the necrosed tissue, or this could be because of just the inflammation. But still, something from the cell came out. So the short of this then becomes that anytime we damage the heart, don't intentionally damage the heart other than you breaking somebody's heart, whenever the heart is under stress, and I mentioned how the pieces of proteins can come out, that can be measured. Now I want to go over, back to the study, I want to go over some data for these 7. Even when you read the study, you'll see that there are EKG changes and there are arrhythmias and all that. That is interesting, but not as interesting for me. And I think even for the authors as well, because authors went into detail of these 7 patients. So here is their table for these 7 patients. So if you see here, this 7 here is the number of patients. Presenting symptoms and signs: chest pain, chest discomfort, pericardial effusion, fluid around the heart, fever, headache, palpitations, dyspnea. And they have the various numbers here. And they have other vitals here. Nobody went into shock. That is good, meaning they didn't get into cardiac failure, which is excellent. Some arrhythmias, fine. If you would like me to actually discuss what did these arrhythmia mean, what kind of damage would vaccine or the spike protein or the autoimmune antibodies or immune system cells would do, I can discuss that later on. I am still very much interested in this. Lab values, troponin levels were increased. Arrhythmia was there. One patient ended up in the ICU. Now, no one died. Now I want to go over this. This is interesting. So I'm going to go one at a time, and I'll go over 2 or 3, and then you can see the table by yourself. Case number 1, 16 years old male, myopericarditis. Myo is the heart muscle. Pericardium is the covering around that. So I actually had this little, let me go back here for a second. I have this little thing here to show to you. Imagine that I should have, let's say this is a heart. This is a heart. This heart is covered with a covering which is very firmly adherent to it. Then there is another covering in which this is present. So, really, inside is the heart. Then there is this little covering, we call it visceral pericardium. And then there is this other covering that is parietal pericardium. And between these two, imagine if in this glass, I have some fluid, some water. So then I put it in here. The benefit of that is that this heart is beating, right? So heart is beating with this little glass as well. And it has to be slippery within the outside, uh, the parietal pericardium. Otherwise, there will be a friction. That friction would cause severe pain, and heart would actually not be able to continue with that for a long time. Now, this cavity, I'm so sorry. This cavity between these two glasses, this space between them, is called pericardial cavity. Pericardial effusion means collection of fluids in that cavity. Many reasons for that. But here, the reason will be inflammation. That means the immune system attacked pericardium or the coverings, and the coverings started secreting these fluids, and the congestion occurred. And that is then resulting in the pericardial effusion. Now, going back here, this table is really interesting to look at. So check this out. 16 male, this male unfortunately ended up in the ICU. His CRP was way high, 86.6, although not way high as COVID patients high, but still very high. Look at his CKMB, 109. So remember, they did multiple profiles on them. Baseline is on the day of vaccination. This was after the second dose. On the day of the second dose, they would take a cardiac profile. Then day 3, then day 7, day 14 was optional. So here they took this. So look at this, 1.25 is normal. Similarly, here on troponin side, 3.18 normal. The day, excuse me, the day of vaccination, child is fine, heart is fine. Within 3 days, so they were doing day 0, 3, 7, 14. Within 3 days, 109.6, way high. Troponin 593. I think normal is what, 14 or so. Pericardial effusion, was a fluid present in the outside. So not only just the heart tissue was inflamed, the coverings of the heart were inflamed. And not only these were inflamed, there was congestion and fluid accumulating in them. You might say, so what if the fluid was accumulating in them? I know that you're not going to say that, but I'm making it up. The problem is this. If a patient, I'd never want to say anyone have it, if a patient has too much of fluid accumulating here, this accumulating fluid would, number one, cause pain, number two, cause disruption of the cardiac function. And now if this patient wants to do exercise, let's say they're not aware of it, and you can ask me this question, that how can this happen that they're not aware of it? I'll show you a case where nobody knew, no other markers were positive, but they had the effusion. So if they had not done imaging, they would not know that this child has effusion. So when the effusion occurs, if you put this heart in stress now, you can end up causing problem for this child or this person, meaning child, adult, man, woman, whoever. Okay, so pericardial effusion, yes. Look at the case number 2. This is very interesting case. 15 male pericarditis. So this is the coverings of inflammation of the covering. Pleural effusion, yes. How did they find the pleural effusion? Because they were doing imaging. If they were not doing imaging, they will not find it, correct? Everything else is normal. Troponin, fine. CKMB, fine. CRP, fine. ESR, fine. Left ventricular ejection fraction, fine. Pleural effusion present. Do you think that this child will be picked up if they were not doing imaging? Even in this study, this child will not be picked up because all other markers are fine. How many such patients? Now, this patient is running around with a pleural effusion. They are at risk then. Then look at this third 17 male pericarditis. CRP is high, not too high, but high. Pleural effusion, yes. And these are subclinical. Subclinical means their clinical signs and symptoms were not present or were really less. Subclinical is before the clinical, right? So they're not saying that, hey, I'm short on breath or I have chest pain or palpitations or such things. They just don't have them. And here the signs of inflammation are present. This has been not shown by any of the studies so far. So we here in the US, we should take some awards and some things and go to Thailand. We should do a tour and give that award to these researchers. Great work. And then you can see the others as well. For example, number 4, 13 male subclinical myocarditis. So subclinical is no symptoms. 0.3 ESR, CRP. Everything is kind of normal, but troponin is high. No effusion. So if you see here, 5 these patients had high troponin. That means inflammation was occurring. They had the signs or symptoms or not, it didn't matter. And this was 2.23%. 2.23%. That baffles me. 2. Here we are claiming one case out of 16,200 something. And here we're looking at more than 2 cases per 100. So author's conclusion, I always put the author's conclusion. We know that authors, one, this study is not a long study. So they do not have long-term data. And they actually say that in their study, that we're not able to provide you the long-term outcome. These need to be researched. And I think they would do some follow-ups as well. This is just in the window of time that they tested. Their message is, guess what should be the message? They would have that standard message. They'll say myocarditis is temporarily associated with the vaccine. So of course not caused by, but we have, excuse me, we have seen other studies. And I think we now agree in the mainstream that vaccines can cause myocarditis in some people. The thing that baffles me is, so I'm baffled by so many things here in the vaccine world. The thing that baffles me is, even after 2 years of vaccines, we still have not in the US figured out ways to realize and understand the vaccine's benefit and cost and benefit in precise ways. We are still looking at wheres, then we dismiss wheres as well. And here, look, what a simple thing these researchers did and came back with concrete data. If the study was done wrong, that's a different thing. You could say, well, throw out the study. But if the study is correctly done, the design is correct, the data is correct, then this is a precious study. We should do more. Maybe we should learn from Thailand. We should ask them to come teach us a little more. Okay, so clinically suspected myocarditis is temporarily associated with this vaccine in small proportion of adolescent patients. Now, do you see the verbiage? In a small proportion of adolescent patients, myocarditis is 1 out of 300. So they can call it small within their own cohort. However, when you compare it to the other announced and observed expected numbers, this is a very high number. And if you take all 7, then it's not small even within this cohort. Chest pain is an alarming symptom in patients receiving BioNTech vaccination, especially a second dose of BioNTech. We found the risk of these symptoms to be not as low as reported elsewhere. They didn't say significantly increased or they're not as low. So again, keep an eye on the verbiage. But in all cases, symptoms are mild with full recovery within 14 days. I actually have a problem with this as well. Sure, this is what they observed. So fine. But if you see here, this is why the Seattle's Children's Hospital study was to say, fine, we saw children that had myocarditis. How long is this going to last? And this is that study. So it's not that it's just really 14 days and we're done. I wish it is 14 days and we're done. And I wish that is how it is. But other studies, if you put them around this study, then the picture is different. So my comments, I've shared them before as well in this talk, but just to put them in one place. Why is baseline and monitoring for heart is not the protocol for vaccines? Remember from the 2020 December, I've been saying that we should have protocols for how to handle thrombosis, myocarditis. So we still are in the same state. Can you imagine? And how many children will be? So this is what scares me. How many children got the vaccine, developed these subclinical symptoms, developed pleural effusion, developed cardiac inflammation, didn't even know and kept doing things? What happened to them? Are they okay? Did they develop some damage? Anything other unexpected happened to them? So that, and honestly, if I can sit here and think in this way, I would hope people in CDC, FDA would look at this and say, you know what, we need to be serious. We need to do more. And vaccine companies would look at it and say, we need to collect more data. Cost benefit analysis need to be redone. Long-term outcomes are still not known. Even in this study, the authors say that, hey, we cannot tell about the long-term outcomes. So this is the talk. I'm going to come back online in soon after this one. We can do a discussion of this. It is already 47 minutes and many people would just not watch such a long video. So we'll come back and we'll do chit chat. I'll also update you about my COVID and where do I stand with that. So please do me a favor. In the description of this video, there is a link to drbeen.com. For a very small amount, you get 900 additional lectures on drbeen.com. So take advantage of that. It is a one-time payment. It's not recurring and you get access to everything. So that is one. And then if you wanted to support this work, there are other links in the description. For example, buy me a coffee or PayPal or Substack or Locals, and you can use them to support this work as well. Thank you very much. And I'll see you in a few minutes again.